This is the Seismic Map of India, which is given in IS 1893 Part 1 2016, which is the latest edition. So you have to first see the location of the area where your building is going to be located, and then you have, using this as the reference, you have to find out the zone in which it falls. So you have the zone 2, 3, 4, 5. So once you know the zone, you can go to table 2 to find out the Z value. So we will assume the zone as 3, so which the Z corresponding to zone 3 is 0.16. So we'll go to this and we will put the value as 0.16. Then you can select the site type. The site type same way go to IS 1893. So you can see the figure 2, which is response spectra for rock and soil sites for 5% damping. Then there are these three graphs for type 1, type 2, type 3. So let us assume, so this we will get from the geotechnical report. Let us assume our soil to be medium soil type 2. Go to ETABS. So site type is 2. So if you go to the drop down box, you have 3. Select the soil type corresponding to your site. Then we have to go for the importance factor. So importance factor you will get from table 6. So you can see two values, 1.5 and 1. So 1.5 for important services and community buildings such as hospitals, schools, monumental structures. So we are taking a higher factor so that the structure remains safe during calamities, and all other buildings. We will go for all other buildings because it's the simple residential building that we are considering. So it remains 1. Then time period, let us keep it as program calculated, and let us go for OK and OK. So in this way, the seismic force is defined. You can go to define and you can add the load cases. Now, if you want to go for response spectrum method, then first you have to define the, you don't, so I will also explain how to do the response spectrum method. We will go for functions, we will go for response spectrum, and we will first choose function type to add. We will go for Indian. Then we will add for new function and we will give a name, RESP. The seismic zone we had discussed, we will keep it 3. So the seismic zone factor 0.16. Importance factor we will keep it as 1. Soil type as 2. Response reduction factor as 3. This is the damping ratio. You can convert to user defined function if you know the values periods. If you have it, then you can put in the value. Otherwise you keep it as it is because that is as per the IS code. So okay, add new function, res 3 3. Okay, so this is added. We will go for OK. Then we will go to define. We will go to if you check in the load cases, you will go for add new case, and the load case we will put as response. The load case type response spectrum. So here in the loads applied, you go for add. This we will keep at as acceleration. Then the function is RESP. So this scale factor you will calculate in this way. That is Ig by 2r, where I is importance factor, G is acceleration due to gravity, R is response reduction. So first you have to check what is the unit of the acceleration due to gravity. So right now we are working with Newton per mm square. So we will take it as 9.81 into 1000 because 9.81 corresponds to Newton per meter square. Then we will put in these values and we will get 1635. So put the scale factor as 1635. Then we will go for model. This we will keep as it is, model combination. Okay, we will add one more. This we will keep as